My name is Shalja. I am physics faculty, and here it is my demo video, and I have chosen the topic of electric current. When we talk about the electric current, the one thing that comes into our mind that is being charge. The current is being due to the flow of charge. The question is, does the time plays any role here? Yes, the flow of charge with respect to time, that is defined as our electric current, or in other words, I can mention the rate of flow of charge is called electric current, which is denoted by I or the capital I, and we write it as the rate of flow of charge, means how much amount of the charge is flowing in a time interval delta t. Here the I is being your average current which has been flowing in the circuit. There is one more term which we use, that is being an instantaneous current. When I talk about the instantaneous current, instantaneous word refers like as being at that very moment, that how much current is being flowing at that very moment. So instantaneous current simply refers that the time interval is being very much small. The time interval is very much small. So the instantaneous current which we use here, it would be written as that the limit delta t tends to 0 times delta q by delta t. Now this limit which we have just produced here, that delta t is 0, refers to that at very particular instant I am talking about the rate of flow of charge. Your current is being measured in ampere. It is measured in ampere, which is denoted by capital A. So we can define 1 ampere. If I just want to understand what is 1 ampere, for that I'll just take the formula for the current, which is being charge upon time or rate of flow of charge. So here I want it to be 1 ampere. I want current to be 1 ampere, and it happens when 1 coulomb of charge flows in 1 second. So 1 ampere could be written as 1 coulomb second inverse. After that one, let us just understand that how does the current flows. For that we'll just consider a circuit. Let me quickly draw this circuit. Here I have a lamp, and this lamp has, here we have a battery, here I have a switch, and here the current would be flowing in the circuit. Here the question is that how does the current is being flowing, whether from here or here. So actually the red line, the red lines is being there, these are carrying the electron. There are free electron. These are made up of copper, or we can say the metals. These are made up of the electrons. So these electrons actually, like as they collide, they are already vibrating, they are colliding and passing on the energy. When I switch on the circuit, the electron from the battery jumps out, passes the energy, and this energy actually transfers, and as soon as the one electron comes out of the battery, one electron enters into the lamp, and as soon as the one electron enters into the lamp, one electron comes out, and then the one electron enters into the positive terminal of the battery, keeping the charge constant. So in this way, we have just seen that the electrons are being responsible for the flow of the current, and electrons have been flowing from the negative terminal to the positive terminal. But there is a one rule which we have to remember, that the current, the conventional current, flows in the circuit from positive terminal to negative terminal. From positive terminal to the negative terminal. Now the question is, when the electrons are responsible in conductors, there specifically I'm saying that in conductors, electrons are responsible for the flow of the current, and still we are saying that it is been flowing, it is just opposite to the direction of the flow of electron current. If the current is being in this direction, then it simply means that it is being electrons in the opposite direction. So what is the reason behind that? This current which we are considering, it is our conventional current. And actually what happened when the electricity was discovered, it was being considered that it is due to the positive charges. And these positive charges are actually responsible for the electricity then. But after, that is more than 100 years, after more than 100 years of the study, researches, everything, when the electron get discovered, then it was being clarified that current is due to electron. Current in conductors is due to electrons. So rather than changing the whole literature of the 100 years, we simply said that the conventional current flows opposite to the direction of the electron, that is from positive terminal to the negative terminal. And to measure the current, you use units, that is being amps, and you use a device which is called ammeter. Ammeter has a symbol. Now after that, how does ammeter gets connected in a circuit? It gets connected in a circuit in series. Now let me just quickly connect ammeter here. So if I just want to understand the amount of the current, so I can place ammeter here. So here is my ammeter. Here the current is being flowing in this direction. When passing through it, and it would be calculating how much current it would be flowing in the circuit. Even I can place ammeter here because it has to be connected in series. I can place ammeter here. I can place ammeter here. All these ammeters will going to give us the same value. So that's a demo video which has been related to the electric current. Thank you and have a nice day.